Mr. Bear.
Yes?
I found some problems where the law of sines doesn't work. What am I going to do?
Ah, I have the answer for you. We will use the law of cosines. Yes, the law of cosines to the rescue. By the way, I forgot to start at my introductory screen, which says that this is section 8.3, the law of cosines. I also forgot to clean up this particular screen. Oh, I'll go back here. Oh, I've really messed this up. But let's examine here, in this particular problem, the law of sines briefly. If I fill in my A value of 2, my B value of 3, and my C angle of 60, and then try to use the law of sines, what I find is that every combination I come up with, I have two variables. With two variables, I am stuck. So what am I going to do? We're going to go to the great and marvelous law of cosines. Hang on to your seats. You better sit down for this. There's the law of cosines. However, it's not nearly as ugly as it looks, really. It looks horrifying, but it's not. Yes, it is. No, it isn't. You just watch this. Watch this. Do not accuse the law of cosines of being complicated. Much easier than it looks. It's three separate equations. An equation for finding C, one for finding B, and one for finding A. To find C, notice the pattern here. It's a really cool pattern. To find C, we get C squared, which means in the end we have to take the square root. C squared is A squared plus B squared. Doesn't that sound an awful lot like the Pythagorean theorem so far? Yes, but it's not the Pythagorean theorem. So C squared is A squared plus B squared. You can remember that. Then we subtract 2 times this guy times this guy. 2 times AB. Then we multiply that by the cosine of the angle associated with side C. That's it. B squared is equal to the 2 we haven't used yet, A squared plus C squared, minus 2 times A times C, times the cosine of the angle associated with what we're looking for. In fact, that's so easy. Let's create that third equation right now. About 10 minutes or so?
20.
20. Okay, cool. Thank you. Being told that I need to pack up and leave before they alarm the building. So we found C squared, we found B squared. Let's find A squared. A squared will be what's left. Well, we've got the A here. We need a B squared and a C squared. Then subtract 2 times this guy times this guy. 2 times BC. Then multiply by the cosine of the angle associated with this guy, which is A. And look how easy that is. Like I told you, it's not as bad as it looks. It looks horrifying, but it's not that bad at all. Let's try using it. Our first example. This time, is this the first example? No, that's not the first example I wanted to do. Oh, I wanted to do this one. Okay. All right, let's find C in this case. Since I've got my A and my B values, let's get C. So we're going to zero in on this guy that gives me C squared. So I kill off these. I don't need them. In fact, I don't think I even need my red rectangle. Let's get rid of the red rectangle. All right, now I fill in what I do know and solve for what I don't. That's all there is to it. We can just stop the video right there. That's all you need to know. Fill in what you do know, solve for what you don't. We have the value of A is 2. We have the value of B is 3. We have the value of A and B, 2 and 3. We have the value of angle C. There's lowercase c, so this must be angle C. And we're off. Now it's just arithmetic. We've got 4 plus 9, that's going to be 13. Minus 4 times 3 is minus 12. Cosine of 60. Now, one mistake you must not fall into because you guys are no longer in pre-algebra. Yeah, you're not in pre-algebra. You're not even in algebra 1. Okay, folks? You do not subtract 13 minus 12. Don't forget your order of operations, I beg you. You must do the multiplication first. Now you can put in your calculator 13 minus 12 times cosine 60 because the calculator knows the order of operations and it will do it correctly. Without a calculator, you would do 13 minus, and then you would calculate 12 times cosine of 60, do the subtraction. Tell you what, to save some time here, because I know that you guys can do 13 minus 12 times cosine of 60 on your calculator. That's not an issue. Trust me when I tell you that you will end up with an answer of 7 equals c squared. So what's c then? Well, if c squared is 7, then c must be the square root of 7, and you are done. If you want to round that to 2 decimal places, just put it in the calculator, and I've forgotten what it comes out to be. It's going to be 2 point something. Does our book tell us what it is? I don't know. It turns out to be, no, they're not even going to tell us. It's 2 point something. All right, another example. This one's a little bit different because they give you no angles. Is it possible to do a triangle? Think through this logic for a moment. If you have a triangle whose sides are 3, 4, and 6, how many different triangles can you make out of sides of 3, 4, and 6? Only one. Thinking back to your basic geometry, the SSS postulate. If you have 3 sides of one triangle congruent to 3 sides of another triangle, those triangles have to be congruent, which means out of a 3, a 4, and a 6, you can only get one triangle. If only one triangle is possible, then it must be possible to find the angles. And it is, using the law of cosines. Let's do it. All right, and it doesn't matter which one we start with. In this case, it doesn't matter which one you start with because we have all 3 of these. We have C, we have B, we have A, so pick one. I'll just pick the top one because it's the top one. All right, so let's plug in stuff. C squared, where is C squared? Here's C, so that's C squared, that'd be 36. Equals A squared, there's A, so that's A, 4 squared, 16. Plus B squared, there's my angle B, so that must be side B, that's going to be 9. We square everything, remember please, it's C squared, it's A squared, it's B squared. Minus 2 times A times B, that's 2 times 3 times 4, and multiply that by the cosine of the unknown angle. So we have 36 equals, let's see, that's 25 minus, there's 24 cosine of C. Let's subtract 25 from both sides. That'll be 11 equals negative 24 cosine of C. Let's divide by negative 24. We get cosine of C equals 11, negative 11 24ths. And now we go to the calculator and we find the inverse cosine of negative 11 24ths. So on my calculator, I'm going to use the second function button, not the regular function. So I hit second cosine of negative 11 divided by 24, close the parentheses, and we get an angle of, according to this C, is approximately, to 1 decimal place, 117.3. Let's verify that from the book. The book says we get for angle C 117.3. All right, so we found angle C. Ta-da, 117.3. We would repeat that process to find either A or B, your choice. Then once you have A or B, you don't need to do it a third time because once you've got 2 of these angles, subtract from 180 and you get the last angle. This stuff is actually pretty easy and close to being fun. I think it's fun, although there are other things I'd rather do, but this stuff is pretty cool stuff. And it's extremely real life. Real engineers, real surveyors, real architects do this stuff because they have to. And it's easy. Well, I thought engineers were doing hard stuff. You mean they're all doing easy stuff? Sometimes. Sometimes. Okay, before wow, that was a short, world-class short section. I thought I was going to run right up until the moment that I had to get kicked out, but I've got spare minutes. Well, instead of boring you by babbling with the spare minutes, I'm going to go ahead and cut you off. Oh, no, not yet. I need to give you an assignment. There it is. Page 523. Numbers 10 through 18 even. Have fun with these. I mean, really, try to have some fun with them. Enjoy the fact that it's real life stuff and it's easy, even though it uses horrifying looking equations. That makes it fun. It looks hard and it's real life, but it's actually easy. That's what makes it fun. Embrace it. Yes. Okay. See you later.